Alright, in the previous lecture we have learned deletion of a node from CircularDoublyLinkedList in 3 different cases. Now in this lecture we will look at how can we delete entire CircularDoublyLinkedList. Now we know from previous lectures that in case of single linked list, if we set head and tail to null, the entire linked list gets deleted. But here in case of CircularDoublyLinkedList, this is not the case. Because even if we set head and tail references to null, the nodes over here is referenced by other nodes. So this means that this will not be eligible for garbage collection. So garbage collector cannot delete these nodes from the memory. So here you can easily see that if I delete head reference, which points to node 1, so node 1 will not be eligible for garbage collection because in this case, node 1 is referenced by last node and node 1 is also referenced by second node. So here all we have to do, we have to delete all links that points to these nodes over here. Now the first thing that we are going to do, we are going to set last node's next reference to null, which deletes a link from last node to first node. So if I set last node's next reference to null, it's going to delete reference that comes from last node to the first node. Now the second step over here is we are going to set previous reference of first node to null, which deletes a link from first node to last node. So if I set the previous reference of this node over here to null, it's going to delete a link from node 1 to node 4 over here, which is the last node. Now after doing so, you see that this linked list becomes double linked. So this is not anymore CircularDoublyLinkedList, so this becomes double linked list. So we know how to delete double linked list. So as you know from our previous lectures, when we are deleting double linked list from the memory, we said that we have to loop through the all nodes of CircularDoublyLinkedList and set previous references to null. Then with this we are able to delete reverse link from each node to the previous node. Then we are going to set head and tail to null, and with this we will delete all links that comes to these nodes over here. Now here, the first thing that I'm going to do, I'm going to start from the first node and loop through first node to the second node. And when we reach the second node, I'm going to set second node's previous reference to null. And with this, we are deleting a reverse link from node 2 to node 1. Then after doing so, we are going to continue to the third node. So here also we are going to set the previous reference of this node to null. And this will delete a reverse link from node 3 to node 2, and similarly we are going to continue to the last node and setting the previous reference of this node to the null, and this deletes the link from last node to the second last node over here. Now after deleting this, our double linked list becomes single list. So in this case we know that when we are deleting single linked list, in this case we are setting head and tail references to null. So here I'm going to set head to null. With this we are deleting a link from head and first node, and then I'm going to set tail to null, and with this we are deleting a link from tail to last node over here. Now you see that here first node becomes eligible for garbage collection, so the garbage collector will delete this one. So after deleting this, a link that comes to the node 2 also gets deleted, so node 2 becomes eligible for garbage collection. Then after doing so, node 3 becomes eligible for garbage collection. Then at the end, last node becomes eligible for garbage collection. So garbage collector comes and destroys these nodes from the memory. Now with this, we have successfully deleted entire CircularDoublyLinkedList from the memory. Now based on this logic, let's implement deletion of entire CircularDoublyLinkedList in practice. Now here, we are going to implement delete CircularDoublyLinkedList method inside CircularDoublyLinkedList class after deletion method. So here in the last lecture, we have implemented the method of delete node. So after that method, I'm going to create a new method, which is called delete CircularDoublyLinkedList. So it's going to be like this, delete CircularDoublyLinkedList. Now it's obvious that it's not going to take any parameter because in this case, we want to delete all nodes from the CircularDoublyLinkedList. So here, the first thing that I'm going to do, I'm going to create temporary node and assign head value to it. So this temporary node's type will be the double node. We are assigning head value to it because we are going to start from the first node and loop through the CircularDoublyLinkedList and set the previous references to null. Then I'm going to write our loop like this. So for I starts from 0 and it continues until we reach the size of CircularDoublyLinkedList, and in each iteration it's going to be increased by 1. So in each step, we are going to set temp node's previous reference to null, and then we are going to continue to temp node dot next. In each iteration, we are going to continue to next node and set previous reference to null. Then after doing so, when we reach the last node and setting the previous references to null, we are going to set head to null and tail to null. Then after doing so, we are going to print out to the console saying that the circle double linked list has been deleted. So I'm going to print out to the console saying that the circle double linked list has been deleted. Now with this, we have successfully implemented a method which is responsible for deleting circle double linked list. Now let's see how this is working in practice. Now in main class, as you remember, we have created a circle double linked list like this. So first we are traversing through circle double linked list to see the elements of circle double linked list. Then instead of delete node method over here, I'm going to call delete circle double linked list method. Then one more time, I'm going to print out to the console to see that if it is printing out to the console or not. So here, if we run our code, you see that first our circle double linked list was like this. Then after running this delete circle double linked list, it says that the circle double linked list has been deleted. Then if we try to run traversal method, it says that the circle double linked list does not exist. So this means that we have successfully deleted circle double linked list from the memory. Now let's see what's the time and space complexity for this method. So as always, we are going to start from the first line of this method. So in the first line, we are creating a temporal node and assigning head value to it. So this means that this will take one time complexity. Then in the next line of code, we are looping through all elements of circle double linked list and updating previous references to null and setting temp node next to temp node. Now this loop will take n time complexity because in this case, we are looping through all elements of circle double linked list and updating the previous references to null. So this loop over here will take n time complexity. Then we are going to continue to set head and tail references to null. So these two lines of code also will take 1 time complexity. And at the end, we are printing out message to the console. So we know that printing out message to the console also takes 1 time complexity. So the last line of this method will take 1 time complexity. Now, if we combine all these complexities over here, we get n time complexity because here this loop takes n time complexity. Now the space complexity is 1 because in this case we are deleting entire circle double linked list from the memory. So an extra memory is not required to perform this operation. So that's why space complexity is 1. Now with this, we have come to the end of this lecture. In this lecture, we have learned how can we delete entire circle double linked list from the memory, and we have implemented in practice, and we have learned what is the time and space complexity for this operation. So hopefully everything is clear about this method. Now see you in the next lecture.